pack, what will happen? You can't fit the battery to your vehicle because that is only designed for that vehicle, right? You can't make change battery from Ather battery to Ola. It is possible? No, their design is different. So that's why pack assembly will be set as at frequent dimension, particular dimension for your vehicle, right? Yes. Then afterward it is used, right? They will be going on testing continuously whether the vehicle can be specific, give you the mileage or not, right? It will give you the performance this one. Then afterward it will be get recycled after 6 years or 7 years after continuously using it, right? You will use the vehicle, right? Two-wheeler IC engines. Afterward the mileage is not giving, you will be just giving to the second hand to the other company or to the scrap, right? And you will get a new one, right? Yes or no? Same thing. You can note this point: the component production, the cell production, the module production. If you have any doubt, you can ask me right now. Yes, clear, right? Finished? Can we move to the next slides? So okay, so this is the first one, the lead acid battery, commonly used, and it is very cheap. Why it is cheap? It's a low maintenance, right? And free maintenance also, right? Is easy availability. You can go to the shops, there will be Excite battery, Amron batteries. You have heard about Amron batteries, right? Excite batteries, those are used, and it is very easily you can get it, and it is very cheap. Okay, so these are the yeah, you can see over here the charging and discharging from electrical energy to chemical energy. It will, while doing charge, after discharge what will happen? It will reverse from discharge, means chemical energy to electric energy for different any batteries, same principles. Okay, and it has very short life period. You have to continuously charge the lead acid battery, otherwise after 2-3 months it get degraded, the lifespan will be reduced. Okay, you may have seen in cars, after you continuously using the battery without running the engine, what will happen? The battery will get dead, and it struggles to start the engine, right? So that's why you have to continuously charge the battery, and that is the short life period. And you can see that here you shouldn't be discharging below the 50%. After that what will happen? The battery will get low, and there is no enough power to run the engines. Okay, this is the common thing in lead acid battery. Yes, have you note those thing points? You can note this point, this also chemistry. What do you mean by PB? Lead, right? Okay. You can note these points, this over here. Hands-on battery station है, right?
Sorry?
Hands-on battery station है, right?
Practical.
हाँ, BMS लगा के इस टाइम.
देखना होगा बात करना.
Clear, right? Shall I move to next slide? Yes, coming to here, nickel metal hydride. As you can see, it has very less efficiency in charging and discharging. That is only used for the clocks and batteries, what I have already have said you. It has high self discharging, which means even if you are not using the cells, it will also degrade, right? And it has poor performance, and that is only the use only for the low power appliances like clocks, your TV remotes and all. So that is only for that is the ideal for the use point. Okay, same as well, if you see over here is the molten salt, what I said, like common salt, hall salt, nickel, irons, and all. Those are all also used in this also comes under these sections. Huh?
Sorry for the
Sorry for the
late.
okay, what is the reason of late?
Traffic jam.
Where is traffic jam? Sure. Okay, so there is no that much discussion on this one because it is not used in the EV vehicle also. Only that is used for the clocks and the normally small appliances which is consuming less power. Okay. Okay, this is the main part of the electric vehicle. You can see over here lithium ion, right? It has high energy density and it is very expensive. Each cell costs more like 106 rupees or 200 rupees. For different categories of size of 32700 or 26650 are rated at different because they are specifically designed for EVs, right? Even also like cameras and so those are very expensive, lithium ion and lithium polymers, because it is a charge and rechargeable battery. That is a secondary battery, first things. Okay, so main part is like we need to know what is the state of charge. What do you mean by state of charge? What do you mean by state? Any idea? Okay, in your phone it will showing you the percentage. What is that percentage? How much battery capacity is there? So that is what it shows you, the state of charge. What is the state of charge of your phone? So can you say me what is the state of charge of your phone? 84, right? How many? Okay, for your 84%, how much time you require to discharge it completely? How much it will take time you for to discharge? Any idea? 6 hours. Any other guys? 9 hours. Why? What is the reason behind? Battery capacity, right? And performance. If you're using a high performance, obviously it will drain very fast, right? And next part is the state of health. Have you seen anybody have iPhones and all? No one has iPhone over here. If you see, yeah, the battery lifespan is there. How much percentage is there? If your iPhone has showing 100%, that means it is very health and good. If you are showing like 60 or 80%, that is very bad because it will stay up to 4 hours or 5 hours, right? That is the condition of state of health. That will be depending upon the internal resistance, impedance, conductance, the battery current integration, how much you're discharging. That will also impact on your health system of your phones, right? What is the voltage, what is the capacity? As I told you that you continue using the battery, life will be get reduced, degraded. So that is comes under the capacity. And voltage, obviously, if you charge or overcharge the battery, it will get heated up. So that also impact on the state of health of your battery. Okay, self discharge is very less. For lithium battery, self discharge is very less. If you keep for at least 4 to 5 days without using it, still it will be reducing up to 2 to 3% only. Okay, yes. And the number of cycle, how much has been discharged or charged. CD stands for CD here means charge and discharge cycle. How many times you have charged the battery, how many times you have discharged the battery. That also denotes the state of health. Okay. And the charge after means how much charge you are giving to the battery. Okay, not more than, if you're giving more than that the battery capacity, it will get heated up and also get fire, right? Yes. Have you noted this point? This will also come, so we will be doing the calculation part also. obviously it is written over here like state of charge, what is the state of health, right? Here down one. So major part will be over here, the performing testings. You will be seeing the state of charge and state of health. High CD efficiency means high charge and discharge efficiency, okay? And actually you can see or not, this actually a discharge part. Can you see the ions moving from here, anode to cathode? Actually it is discharge. For charging, what will happen? It will reverse it. Lithium will be moving towards the anode and electrons will be flowing from this side, right? Yes. And this battery can last up to 5 years and more than that, depending upon the manufacturing, okay? Printer में Yes, shall I move to next slide? Okay, so actually don't consider this one right now, the motor specification. Go for over here with the battery specification, right? If you see here, what I have mentioned is the battery pack consists of total 364 lithium ion cells. 364 means number of cells present in the battery pack. So in this battery, let us consider this one is battery around 72 volt and 30 Ah. Okay, and I have taken this one cell, the 3700 cells. It's tagged and kept inside the battery pack. Okay, so there will be a number of cells, but in order to get the higher voltage like 48 volt, what I have mentioned over here, the 48 volt, and this cells only has 3.2. In order to get voltage rise, the number of cells has to be increases, right? In voltage, what will happen? The series gets increases. So how many times you have to increase till 48? So how will you get it the 48 volt? How many numbers of cells required to get 48 volt? 16, right? How? The total battery of what is the requirement of battery voltage by 3, like 3.2, and that is your answers. It will maybe coming around 12.1 or 12.3. We can consider as a round off of 12 or 13. Okay, yes. For and you have mentioned over here like what is combination of cells 13S and 28P. Any idea on this one? What is that meaning? Basic like logically you apply your mind. What do you mean by here 13S 28P? Sorry, yes. Series and parallel, right? Yes. In parallelly you require a AH more because this cell has only 6 AH. In order to get 30 AH, how will you increase? Parallelly, because current will be flowing on parallelly, not in series. If what happens if series breaks down, there is no power supply, there is no current flow in one direction. So you require parallelly to get a series combination of 48 volt or some other battery voltage specifications, right? Yes. Yeah. As I said, to make battery pack, let us take 48 volt. So this is my specification. I require a one battery pack of 48 volt 30 Ah, right? You guys gonna make one battery pack, right? So in order to get, you require one cells, right? You will go to the vendor shops and you will get one cells. It could be anything, 18650, 26650, 32700, right? It could be anything. So in order to get, let us take, I have taken 18650 and its their specification is around 3.6 volt, 2.5 Ah, or you can consider as 2500 milliampere hour, right? It could be anything. In order to get 48 volt, 38 volt, how will you do? Any idea? Can you guess it? I think you are from electronics department, right? You will just apply the logic. How will you get the 48 volt and 30 Ah? What is the number of series and what is the number of parallel? Easy, right? Or still confused? Any response I require? Any idea? Or should I say?
We need 48 volt 30 Ah battery pack. In that, each cell is of 3.6 volt 2.5 Ah. So how many cells are required in series and how many in parallel? As you see, 13S 28P.
You have given me the answer, right? Obviously, you have given me the answer. In series, you will be adding how much? 16 you have given. Yeah, that's why I'm asking it. 12. Okay, 12. What about the parallel? Because in 12 series, in one parallel means that is around coming around 48 or 6 Ah. But I require 30 Ah because current will be flowing on parallelly, right? Yes or no? Okay, let me clear you guys. I'll make one battery pack for myself from small one. Consider you're going to make one power bank for yourself, right? The power bank will be having around 12 volt, right? Obviously, this single cell has around 3.6, 2.5 Ah, right? I require 12 volt. To increase the voltage, how many cells you require? Calculate it. Take your phone, calculate it. Total number of battery pack value by 3.6. What is the single cell value? 3.6. Try. No, exactly you give me the answer. Four. No, exactly it will be coming around 3 point something. Sorry. Exactly 3.3. So okay, we will consider as a 3 only. That means 3 in series. Series means what? Voltage will be getting increased. So what will happen? This my arrangement. This cell 1, cell 2, cell 3. So each will be having 3.6 volt, 3.6 volt, 3.6 volt. What is the total voltage then? 11 point? 10.8. Okay, still we are lacking it. Can we increase it another one? Okay. Let us increase to cell 4. That means 4 in series. Can you see this is in series? Yes or no? Yes. So what is the total voltage right now? 14.4. Okay. We will consider the 14.4 for extra voltage. Right? So what is the value of right now over here? This means 4 in series, 1 in parallel. Because this in 1 in parallel, right? Obviously. Yes or no? Right? So this value will be coming around 14.4. I haven't mentioned here. 2.5 Ah. Right? This is the capacity. Okay. Can you calculate the power? Power is easy, right? What is the power formula? Power formula. You don't know power formula? Work done by? Time. Okay. In electronics, P is equal to V into I. Right? So what is the voltage over here? What is the voltage? 14.4. What is the current? 2.5. Calculated. What is the power? Have you seen the battery power bank? 10,000 milliampere hour, 6,000 milliampere hour. In down it is written some power, right? How much power is there? You haven't guys gone through those things, right? Right? How much? So these are only a 36 watt. Okay, 36 watt. But I require 10 Ah, right? How will you increase 10 Ah? Same principle. Yes, total number of, like, what is the requirement of mine? 10 Ah, right? 10 Ah by, what is the cell Ah? 2.5. What is the value? 4, right? That means 4 in series, 4 in parallel. So you have to connect another cell over here. Same. Can you see it is connected in parallelly? Are you confused in this one, series or parallel or not? And you have understood this one, right? Yes. So this one over here, you have to connect the total number of 4 in parallel. So another over here will be there. Same as well. So now you tell me how many cells you require to make one 12 volt and 10 Ah? 16, right? So you require 16 cells to make one battery pack of 12 volt of 10 Ah. That is the standard, nominal standard. So what is the total battery voltage? 14.4 10 Ah, right? So these are your battery specifications. Okay, so this how you are going to make one battery pack. I have mentioned you, right, how the cell is production is going on in the first slides. This is the assembly line, how you are going to make the battery packs. This is the small basic concept of how you are going to make a battery pack. Okay, clear? I'll give you another task. Can you make me a 48 volt same value of 10 Ah? These all are basics. How many cells you require, how many series you require, how many parallel you require. Parallelly, I think you can get it, right? I have showed you 4 you require, 4 parallel. How many series you require to get that total number of battery voltage? How many cells you require in series? Exactly you give me, don't give me 13.3, right? So we can consider as 14. Okay, that means 14 in series, 4 in parallel. So how many total number of cells you require? Just multiply it. 14 into 4, how much? 56. So total number of cells you require 56 cells. This is the basic concept of making a one battery pack. Okay, as I have shown you here previously, this one is the damaged one. You can see the number of cells has been stacked, and these actually are spacers. We have the spacers, right? Okay, actually this is for NMC spacers. This is what you call spacers, to arrange the cell in one module pack. You can see the arrangement. It will be having series or parallel conditions, right? And I think you can see the negative part. This is the negative and this is the positives. Okay, 1 2 3 4 5 6 7 8 9 10. 10 in series, 1 2 3 4 5 6 7 8. 8 in parallel. 10 series and 8 parallel. This is the one module pack, battery pack. Okay, so this is actually a spacer which is fitted inside the battery, or you can say cells, like this. You have to arrange from your side also. Clear? This is called as spacers. Have you seen Lego? Have you played with Lego? Same thing. Just attach it, make it arrangement, and finished. Okay. Doubt clear? Okay. Can you make for your own battery pack dimension? Very simple, right? Go ahead. Can you make your own battery pack? Very simple, basic concept I am going only. Okay, I will give the task. For first benchers, my requirement is like I have my 72 volt. Okay, let us take this cell only for you guys. Okay, you have those one, and then this another one is battery pack. Okay, last person is, so it's not written your AH, is written in watt hour. You can convert it, I think so, right? Yes. The thing is, right now you have one cells, right? Different specification data sheet is written, right? There is a 3.2 LFP, and you have 3.67. Okay, sorry. You have 3.6. What about you guys? Voltage. 3.4. 3.7. Okay. Can you make a 78 volt 30 Ah battery pack? 78 volt 30 Ah battery pack. What is the configuration of series? What is the configuration of parallel? The number of cells. Very easy, right? 72 volt 30 Ah. And what are the, you have the cells, right? Those are nominal voltage, that is not a peak voltage. Okay, the peak voltage total is different. I will show you the data sheets. Sorry?
72.
Yeah, it is written over there, right? That's why I have given you. AH is written, battery volt is written. The last person has written in watt hour. You have to convert into AH. If it's very easy. I is equal to P by V, right? That's all. What is the voltage? 3.7. What is the watt hour? Okay, just write a watt. 60.28, right? 60.28 divided by 3.7. That is the AH. You will get it. You forgot, right? You are from electronics department. You know the power consumption, right? For small electronics consumption, you have to get it. 4.4 AH. Or you record 4400 milliampere hour, right? Simple. Okay. You have written in one day only. You have plenty of days.
Only 5 days. 5 days.
Oh, you have brought for 5 days, means 5 days.
They give 5 days.
Okay, no problem. Wait. Please note it down on your notebook. I will see it.
72. 20.
What is your cell specification?
3.2 volt.
Okay, 3.2 volt and 6 Ah.
6 AH.
Okay, so how you have done it? Total of battery packs, the value, and by number of cells, single cell voltage of how much? 3.2. That means come. Okay.
5P.
5P.
23 into 5 and 1 cells.
Okay, now that cell has the cost of one cell cost of around 208 rupees. What is the total size?
23,900.
And you can guess it out. What is the price, right? Lithium ion battery pack, very costly to make it. Number of cells into the price. That's all, finished. If you have doubt, ask me. What happened? You still doubt? Series and parallel. I'm getting sweated over here. 5 parallel. 13 into 7. Okay, 13 into 7. 91 cells. Okay, good. You require 13 series in 3.7 volt, right?
Yes.
And 7 in to get it to make one battery pack. That means you have to make 13 in series, 7 in parallel. So this is how you are going to make. Okay, that cost around 216 rupees. How will you calculate it?
216 or 260?
Yeah, 216. I think it's very easy to make your own battery pack. This is a very simple battery pack to manufacture it, right? If you see even over here, if you see over here, this one is the one battery pack I made for power bank, right? Okay, clear? Finished? How many number of cells you require? Okay. 70. Okay, you have written 78. I said 72. Okay, no problem. The value will be correct only. 21. Yeah, 21 series you require. 22 series you require exactly. And 6 in parallel. Fine. Yeah, no problem. You make 78 volt also. The value will be correct only. You have written for your own, right? 78 volt 30 amps. That means you're making for 78 volt. And the value, how much is you're getting it? Series. Okay, 21 series. That's all. Nothing. No worry on those things. Yes, clear, right? Everybody clear on those things? How to make one battery pack? Still confused? Last person. Yes. The main part is right. Yes, listen. The main part is making the battery pack okay. But what about the size? You have to depend also in the size also. Have you seen any Ola or Ather that batteries on the compartment, the storage compartment? No, right? It may be having flat or triangle, right? So same thing. Can you make the dimension? Okay, what is the dimension? You have made that calculation for you, right? You have 32700 and you know the model, right? 32 in width. What about you have? The model number. You don't know the model number, you're late. 18650. Oh, that is the 18 mm. And what you have right now back? Third bench. 26 is the width and 650 is the height. Okay, what about you guys? Last one?
21.
Okay, that is different one. And that is NMC one. 21700. 21 is the width and 700 is the length. Means 70 is the length. Okay. I think so. You made the cell configuration, right? How many series?
23.
For you it's 23 series, right? And 5 parallel. Can you make that dimension? What is the exact dimension? Make it circle only. Matrix, right? How many you have? 23 series, right? And 5 parallel. That means it will be coming like this. And what is the exact dimension? Length you leave it. Height one part. What is the dimension? Can you make it? Same for you guys. 20 12 parallel means 21 series and 12 parallel will be having like this. Can you make the dimension? Top only. Got it? Last benches. Dimension. Can you make the dimension? What is the battery configuration for you guys? Battery configuration, series and parallel. 20 series and so can you make the dimension for that one? Battery pack. Just circle part, top right. Battery dimension. Don't know. Actually, this one is your cells, right? 13. You have made for 13 series, right? 13 means 13 in series. Continuously make it. What is the and you know that this is the 21 mm. 29 into 13, how much?
26
Something 26 mm will be coming. So that is your length, height or something, right? And this is the width.
70.
So means 21 into that is 21 only. Circle only. You're not going to like do it like this circle only. For example, I would say, see here is here. Can you see the dimension of this battery pack? This actually 18650, right? And can you see this on a circle over here? What is the dimension of this one? 18 mm. So 18 mm this section and 18 on this section. This in series and this in parallel. Can you make this one dimension? What is the total dimension what you have written right now? The series configuration, right? Battery configuration. Can you make it the dimension? What is the dimension of this one? Yeah, I require dimension. You have the battery configuration, right? Yes or no? You have the battery configuration or not? How many series you have?
23.
23 series means 23 extra will be coming here. What is the length I require? Length and width?
650.
650?
14,950.
Okay, that is in mm, right?
Yes, sir.
Okay. What about here with
130 mm.
130 mm? Yeah, for you?
21 series and 12 panels.
Yeah. What is the width and dimensions?
21
मेरा अरे भूल गया रे मेरा कहाँ गया अरे यार वो भूल गया भाई सीरियसली मैं भूल गया अरे नहीं रे फिर लॉक हो गई तो मेरे को खोलना पड़ेगा पासवर्ड से मैं भूल गया भाई
चलो कोई बात नहीं आवाज़ जा रही है
Yes, still confused. Okay. Okay, wait. What is the configuration you have?
1360 is the
21? 21 series, 12 parallel. So you are considering 21 series over here. What is the length over here? Right? And how much parallel? 12 parallel. What is the dimension over here? Can you make it? This is the circle part, right? What is the cell you have? 18, right? 18 into series how much? 21. And 18 into parallel how much you have? 12. That is the dimension. That's all. You can convert into mm or centimeter. That is on depends upon you. Yes. 12 parallel, right? And you have the cell of 18650. That means 21 in series like this continuously. I have shown you, right? Okay. So these what is the dimension? 18 mm. 18 mm. So 1, 2, 3. How much you require? 21, right? That means 80 mm into 20. How much is what is the value? 378 mm. This is my length. Width how much is there? 12 means 12p, right? Same exact it will be coming. So how many? 12 into this. What is the dimension of this one? 12 into 18. 216 mm and 378 mm. That is your dimensions. Simple, right? Done, right? Can you make? What is the value? What is the battery configuration you have made? What is the battery configuration? Series and parallel. 21.6 and okay, let us consider 21 and 8. 21 in series, 8 in parallel. So what is the dimension? Just multiply it and that's all you will get it. Yes, okay. You got it? What? Phone. Yes. Please wait.
this is the configuration.
Yeah, 26650. 26 is the width and 650 is the length. I have showed you, right? I have measured you the through vernier caliper. Is the 26 is the width. Correct, right? Exactly, it will come. Some error will be there. 21.6. We can tolerate it. And length, how much is there? I don't want to short circuit. That's why I'm keeping a little bit far. 65, right? So this is the. Yes, you were asking something.
Sir, how to calculate length, sir? 21 700.
700. Where is the cell? This is the different one cell. This is 21700. So this is the 21. Right? Exactly 21 will be coming and 700 will be this much. I don't want to make short circuit. That's why I make it exactly 700. So you have made the battery configuration, right? 21 series and 7 parallel. That means circle will be in top size. You can see the battery pack, right? Obviously. Let us consider you having like these cells. This means these in parallel. Can you see over here? This is the negative part, body is negative part, and front one is positive part. So this means series connection. Sorry, this is in parallel connection. This is the series connection. How many series you have right now?
21.
21 series means 21 will be having on this length. And how many parallel you have?
Parallel.
7 parallel means 1, 2, 3, 4, 5, 6, 7. Till here you will be there. What is the length over here? What is the length of this one? Just circle part. What is the one? This one? 21. 21 into 21. How much is coming? 441 mm. Okay. And same as well for 7. You don't require length. Length will be like you're calculating like this. And that will be having width will be only 21 mm only height. Okay. So you have to consider like this only. So how much it will be coming? 7 into 21?
7.
Yeah, because here is the width, right? This you are making parallel. These parallel, right? Can you see?
147. 147.
Oh, yeah, that is the mm. So that means you are designing like this, single cell stacks. You're making like this, very length. You're not considering like this. So that's why you are calculating wrong. So 18 mm will be like this. Height will be like this. So this is the battery pack size. Okay? Yes. I think everybody clear on making on battery dimension and all, right? Very simple. Okay. Okay. So major part is like you have made the battery pack. In order to control the battery pack, you require some BMS, right? What do you mean by BMS? Any idea? Battery management system, right? It controls the overcurrent flow, how many charge, how many discharge you are making from the battery pack. That need to be controlled. Otherwise, if you disbalance one cell also, it get overheated and get flame also. And it also particularly it also damage the other cells. Yes.
How do you make the terminals?
Sorry.
How do you make the terminal like positive and negative?
Sorry.
How do you make the terminals?
Terminals. Very easy, right? What is the end voltage? Let us consider I have 3 series, 2 parallel. Can you make on, I think you don't have the pages, right? Okay, let me add now. This in 3 series, right? 3 series and 1 parallel. Okay, in order to get 2 parallel means I have to beside I have to connect another one, right? So this is the battery negative and this is the top one, B positive. Yes, what is the total voltage right now here? Consider this one only. What is the battery voltage right now? Series means how much voltage? 3.6 into 3, how much? 10 point?
10.2 means
Okay, 10.2 voltage. So this is my battery voltage is around 10.2 voltage. What is the AH then? What is the total AH? 2 into 2.5, 5 AH. Right, so this is the total battery voltage of around 2.2 volt of 5 Ah. So here you will get the total battery output terminal, B positive and B negative. You can't even take middle. If you take from middle, this will be different. Let us consider on this one over here, this one node over here, one node over here. This is the B negative and this is the B positive of single cells. Right, so what is the voltage of over here, this cells? 3.2 and what is cell value? 3.2 and 2.5 Ah. Right? Same thing. So you have to take total number of output cell of end point. Okay? Not in middle point. Clear? Yes or no? Clear? Okay, I will show you the that is fixed. Okay, leave. Have you got clear on these things? What is the output terminal? End point. You have to take only end point, total battery pack. Yes. No, this one. So okay, so BMS stands for battery management system. In order to control your cells, right? Even if one cell also get damaged, everything will, other parts of the cell will also get damaged, right? For example, let us take this one only. This one, the cell is damaged. Okay, you can't also change the battery pack. If one cell gets damaged over, you can't take it. You have to remove everything, and that will totally waste. You have to get one new battery pack. Okay, so that's why you require a BMS to protect the battery pack. Okay, so most thing is like it is a safe operating area operation. Okay, can you see this BMS over here? Yesterday I have shown you, right? This is the higher capacity one, and you can see over this one is the small over here. Actually it's a small one BMS over here, this part. Okay. So this will handle what is the state of monitoring. Like state of monitoring means what is the cell voltage, what is the capacity, what is the state of charge, what is the state of cell of each cell, not the battery pack, each cell. Okay, then it will go to the data reporting. It will show you the data reporting, how much you have cell has been drained, how much cell has been properly functioned, what is the efficiency of the each cells. Those are all our data has been monitored. Okay, the major part is only thing is balancing the battery pack. Okay, balancing the battery pack means maintaining the voltage, exact voltage. If one voltage also get drops, like for example, let me draw one battery cell pack over here. So this around, let us consider 3 series only. This around voltage is around 3.6, 1.4 volt and 3.6. The major impact will be having on cell 2 only. Okay, obviously you can see the voltage is less than 3.2. That is the nominal voltage what you have right now, right? 3.2, or some may be having different configuration, 3.6. Typically every each cell have at limited up to 2.2 volt or 2.6 volt. That is the dead cell. If this cell has been damaged, the whole battery gets cut off, right? So there will be no power in it. Okay, because it is in one series. If two parallel means also, that also impact in the battery arrangement configuration. Okay, so that's why the BMS is the main major part in the battery pack. Okay, that's why you have seen in the Ola. I think Aether haven't have any issue with the battery because you haven't seen news on the Aether's complaint or customer is complaining about. Major part is like Ola and different type of, like any other vehicle you have heard about that. Okinawa, heard about Okinawa? Okinawa you haven't heard. Small part will be there. Some Kumki also is there. Yes. So those will be impacting only the BMS due to what? Overheating, overcharge, over discharge. So that's why you have to maintain the every cell through BMS only. Without BMS you can't make one battery pack, right? Okay, so these are the major part. You can note this point. State monitoring means the state of health, what you have written on the back, the state of health, state of charge, high efficiencies, how many charge has been charged, discharge, life cycle. Those are all monitored by state monitoring only. Okay. No. Okay. Clear? Okay, so these are the points, the major points over here what I have said you. First of all, it comes under voltage. What is the total voltage? I have showed you right, the total number of voltage. What is the total voltage of your battery pack? 72 volts or 78 volt, right? So this all comes under over here. Total voltage. What is the total voltage of individual cells? I have said you right, 3.6 volt, 1.4 volt, right? What is the minimum maximum cell voltage? Each cell voltage have different value. Maybe it come around 3.6 or 3.4 or 3.45, right? Those are monitored by BMS only. And what is the cell voltage, cell under voltage, periodic lags, right? And next step is temperature. Even if one cell get temperature is more than high, we can't shut down the whole part, right? It may be maintaining the battery pack. Okay. So this is the temperature over here, average temperature. What is the average temperature over here? like 46 volt or sorry 36 temperature 36 degrees Celsius or 37 degrees Celsius. Typically every electric vehicle have maximum of 60 degrees Celsius handling. This LFP can withstand up to 200 degrees Celsius. Okay, this because of LFP. For NMC, how many are having NMC? I think so 26650 and 21700. Those can withstand up to 400 degrees Celsius. That's why after more than that it gets caught fire. Okay, for polymers is totally different. That can withstand up to 200 degrees Celsius. Okay, yes. Okay, so here is the state of charge. What is the depth of charge? Indicating the charge level of the battery pack. For example, your percentage of your battery pack, iPhone or Android, 100%, 80% or 60%, right? Yes or no? I think it will show you the color grade also. In 100% it will show you the green. After 20% or 50% it will show you yellow. Then afterward red, right? So this is the level of the charging level of the battery pack, right? State of power. What is the total power? I think you have calculated the power, right? No, nothing. Voltage into how much AH? That will give you the power, total power. Yes. Okay, calculate for that power. V into I, right? AH. Where have you written? Yeah. Okay, that is right. 78 volt. 72 into 30 was the total voltage. Oh, how much? 2300. 2.3 kilowatt hour. That is the state of power. Okay, that is your power battery pack. For you? 21? Okay, 2.16 kilowatt hour. Here's your battery pack dimension. Yeah, third bench. 78 volt. 30. How much is coming? Yes, last bench. 2000? 3000?
2340.
2340. Okay, that's been 2.3 kilowatt hour. Okay. Yes. So those are this also monitors your battery pack power, right? How much power you are draining it. Okay. Next come to state of health. Same. What is the percentage of your battery pack? Next come under current, right? How much current is delivering it? If more than that, what will happen? It will cut off, right? Anybody have ridden an electric vehicle? Any of you? Okay. After charging it, you have gone through many miles or many kilometers. You might be feeling the power dropness, right? Yes. Due to what? There is a sudden drop in the current, a sudden drop in the power. There is not enough power or energy to produce your vehicle to run, right? It will stop, again it will start, again it will stop, right? It is recovering it. Okay, it is recovering from the cell through what? BMS. Okay. Yes. Coolant will be coming under air fluid or fluid also, all called gel type. Okay. For maintaining for the temperature control, you require air cooler. Right? Clear? Yes. So these are the points for the BMS monitoring. You can note it these points. Have you written? Or shall I move to next slides?
किसी को डाउट अभी 5-10 मिनट डाउट ले लो माइक पे ही पूछवा लेंगे
Yes. लाइट ऑन कर दे.
लाइट ऑन कर दो
हाँ, कुछ नहीं होगा. I think it's visible, right? Okay. Anyone if you have doubt? Doubts? Yes, you have doubt.
No doubts till now.
Obviously, there will be doubts.
टेस्ट कर लेते हैं.
Okay. Then I'll be giving the task for each individual to make one battery pack. Right? Okay. Then let me open one data sheets. कैसे खोलूँ? Yes. Yes. Yeah. This is one of the data sheet of 32700. Wait. Yeah, it is a 32700. 48. Okay. Can you see that 32700, right? That is the one of the data sheet of this one over here. Nominal capacity is around 6 Ah, right? It's written correctly, exactly, right? 6 Ah. Yes. And these are all the tests we have to go through, that whether the battery has a good quality or not. And nominal voltage you can see is around 3.2 volt. And if you see that end of the charge voltage is around 3.65, and that is the standard voltage. That is what is written over here in the battery pack is all our standard voltage. 3.2, 3.7 or 4 point something is written, right? So those are standard voltage, and that is the peak voltage will be around 3.65. Okay, you can see over here this is the constant charge mode. It is around up to 3.65. Okay, 3.2 to 3.65. This is the peak voltage. Okay, and it can discharge up to 18 amp. One cell can discharge up to 80 amp. Okay, it's written over here the data sheets and all. If you see the life cycle over here, there is 1C, means 100% of depth of discharge around 2000 cycles. You can charge and discharge around 2000 times. Yes. Okay, you can see the charging temperature. What is the charging temperature over here for single cells? 0 to 60 degrees Celsius, right? Okay, and discharge temperature from -20 to 60 degree, and it is only capable of 60 degrees Celsius. Right? Okay, next I will show you the video of the battery, how we build and how we'll maintain the cell, each cells. The day I have showed you the prismatic cells, right? Light off. Well, I was equalizing the every battery cells, right, to maintain each nominal voltage 3.2, not more than 3.5, or tolerance I can make it up to 0.05 volt. Okay, so each cell need to be balanced. So this is the equipment of balancing it. I think you can't see it, but it is written over here. This is the total battery voltage of 81.6 volt, and it is charging it. You can see over is minus 20.7 20.7 amp. Right. So this is actually a one type of a BMS only. So you can see here. So this is the total number of cells is 24 volt of this battery pack. Right, you can see over here the wire connection. Each cell is connected within the BMS. Right, I'm maintaining the cells to get balanced. Okay, so this is the balancing charger. You can see, right, this is the negative terminal, this is the positive terminal. Right, can you see it? Black color over here. Yes, and this is the output from negative to here. So this I have made on diagonally, and this is the what I made on separator over. You can see the separator part. So each cells are connected at series connection. There is no parallel. This is 1P only. Okay, so this is the prismatic cells one. It is possible to rotate or not? Forward record speed. Wait a second. Yes. I think so. It is okay. Yes. Can you see it? What is the every cell voltage? You can see the number of 3. Yes. At cell number 1, it is around 3.4, right? At cell number 2 is around 3.399. I'm maintaining the cell battery voltage. Okay. This is a balancing. You can see the number cell 3, 3.402. And this around 4 series, 4 number of cell 4 is around 3.398. So I'm maintaining the cells to be balanced. Okay. Without balancing, you can't maintain your electric vehicle to charge, right? So first of all, while doing the production, you have to maintain the balancing. Okay. So this is the balancing equipment. You can see over here is a total voltage around 81.6 volts. Can you calculate it for this one? 24, 3.2 into 24, how much is coming? What is the battery voltage, total battery voltage? Sorry? 72. That is the nominal voltage. That is not a peak voltage. Peak voltage will be around some more than that, 4.1. Can you calculate for 4.1? 4.1 into 24? 8. Okay, that is not a 4.1. I think 3.6. I think so. 3.65 LFP. Sorry. Okay, that is, I think that is the one of 3.6. Okay, you can see exactly, or you can calculate for this one 3.4. Every say average cell is around 3.4. 3.4 into 24. Yeah, exactly, right? And you have got the value over here, exactly, right? So I'm balancing it, right? Okay, so these around 24 cells and the rest of are like 26 and 27 are null, because my cell configuration is around 21 series and single parallel. Okay, clear? You got the idea, right? Yes. And another one machine is there, like battery aging testing. You can see that I have around 100 Ah and this around 71.52 Ah is there. Still remaining capacity is there, and that is the percentage around 72 volt, 72%. Sorry, right? And you can see the MOSFET temperature and the real temperature of the every each cells around 33 degrees Celsius. Okay. Yes. One more machine is there, what you call battery aging testing. That is the final battery aging testing. We'll get the output. And that is the charger. Yes, that is the machine over there. That is the battery aging testing. If we haven't gone through the battery aging testing, I have done for this one only. Okay. Got clear on this video concept? Right. Okay, so this the data sheet of the 32700. If you see over here, they will be testing it. They will be testing the every steps, like external short circuit test, whether it is getting explosion or not. No explosion, no fire. Cell shall be charged at I think that page number 3.2, that it has been short circuit at the particular frequency or not, 5 milliohm for 10 minutes. So there will be a criteria like no explosion, no fire. So these are all the steps, like overcharging test, over discharging test, crash test. Crash test means what? You're dropping it, whether your phone can drop from this height or not, whether it can withstand or not. Shall we try? No. Okay. So these are all the tests we have, the company will go through, right? Heating at 130 degrees Celsius, which is more than 100 degrees Celsius, right? So you can see that there is no explosion, no fires. Okay? Yes. Got clear, right? Any doubt? Okay, the BMS Y diagram I will show you tomorrow. Okay. No, not this one. Okay, I will give the individual task to you guys. Uh, I think I have given you the nominal voltage and peak voltage, right? Okay. For you, one cell value is around 3.2 volt and the peak voltage is around 4.1 volt. Okay. This nominal you write it. And this is the peak voltage. And AH is around 2.5 AH. Make a battery pack of 68 volt, 25 AH. Yes, for you, nominal voltage is around 3.6 and the peak voltage is around 4.2. AH is around 3000 mAh. Battery pack voltage is around 24 volt, 60 AH. Yeah, 60 AH. Yes, for you, the battery pack, okay, battery pack voltage you written, right? Make me a battery pack voltage of around 48 volt, 15 AH, and cell value is around 3, nominal is 3 volt, and peak voltage is around 3.65. AH is around 2.5 AH. AH. Single cell AH, 3 AH. Yes. For you, nominal voltage you can consider as 2.9. Peak voltage is around 3.75 and AH is around 4.2 AH. Make me a battery pack of 16 volt, 20 AH. For you, nominal voltage around 2.4, peak voltage around 3.3, AH is around 4.4 AH. Battery voltage I require 26 volt, 36 AH. For you, 3.6 volt nominal voltage around 3.6. This nominal standard, and peak voltage 4.1. AH is around 2.5 AH, and I require a battery pack of 36 volt, 25 AH. 36 volt, 25 AH. For you, nominal voltage around 3.5 and peak voltage around 4.1. And AH is you have written? No, 2.5 AH, yes. 2.5 AH, yes. Make me a battery pack of 36 volt, 20 AH. Yes. For you, nominal voltage around 3.65 and peak voltage around 4.25. 4.25. AH is around 5 AH. Battery pack 76 volt, 42 AH. I require battery power, total power, number of cells, number of series configurations, and dimension. For you, write it down. Nominal voltage around 3.25, peak voltage around 3.9 volt, AH is around 2.5 AH. Battery pack I require 24 volt, yeah, 24, 36 AH. Oh, you have written same. Reverse the, okay. Make this one peak voltage of 4.2 for you, 5 AH. Okay, go ahead. For your nominal voltage, you can consider as 3.1 volt nominal. That is not peak. Okay, peak voltage around 4.25. AH is around 2.56 AH. Battery pack I require 36 AH and 72 volt. Okay, for you nominal voltage around 4.1 and peak voltage around 4.6 volt. AH is around 5 AH. Battery voltage I require of 110 volt, 26 AH. For you nominal voltage around 3.65, peak voltage around 3.95. AH is around 6 AH you can write, and battery voltage around 36 volt, 200 AH. Yes, you right. Nominal voltage around 3.2, peak voltage 4.2, 6000 AH, milliampere hour, sorry, mAh. Battery voltage I require 200 volt, 36 AH. Okay, for you nominal voltage around 3.7, peak voltage is 4.1, AH is 1000 milliampere hour, mAh. Okay, peak voltage voltage I require you write it down. I require a battery configuration of 12 series, 8 parallel. Okay, what is my battery pack voltage? I haven't given the battery pack voltage, I have given the battery configuration. .5 volt nominal, peak voltage around 4.2, AH is around 4 you can write for AH. Battery voltage around 20 volt, 36. For nominal voltage around 3.65, peak voltage around 4.25, AH is around 3.5 AH. Battery voltage I require 46 volt, 25 AH. 46 volt, 25 AH. For you nominal voltage around 3.1 volt and the peak voltage around 4025 milliampere. Okay, and AH will be around 6 AH. Battery voltage I require, don't write battery voltage, battery configuration you can write it out, 36 series, 2 parallel. You can get it right. Yes, you right. Both of you write it. Okay, no problem. I will give you. Peak voltage is around 4.6 volt and nominal is around 3.5. AH is around 10 AH. And battery configuration you write it down. 15 series, 5 parallel. For you same 36 series battery configuration, 2 parallel. Battery nominal single cell single cell is around 3.6 nominal, 4.1 peak voltage and AH is around 2.5. Okay, so I require battery power total battery power, number of series. For those who have given you the configuration, right, what is the total battery pack power, okay, and the dimension and the cost.
is 3.65.
Sorry.
Peak voltage.
Yeah.
Utilize this value. We got all three values.
Yeah, all three values are required. What is the peak voltage? Nominal voltage, that is the standard voltage, right? Every each having only standard voltage. So let us consider this home plants are working on 230 volt. But what is the total peak? What is the peak voltage? 1 by root 2, right? Have you gone through?
311.
Yeah. Yeah, 311 voltage. That is the peak voltage. But we are not considering as the peak voltage. We are going to the RMS. So that's why for this one in DC is linear. This is different. That is the average value for RMS. Okay. So same thing for this one is the total battery peak voltage around 3.65. But there will be a little bit big difference will be there. What is the big difference? What is the voltage difference over here? 3.65 and 3. Well, 6.65 voltage will be increased. What is the 0.65 voltage will be increased? What is the value? You haven't done.
Can you use this one?
Yeah, for this one, what is the battery pack voltage? Total battery pack voltage.
What we have to do?
Yeah, nothing. 3.65 into how much? 16. That's all. Okay, I have given you the peak voltage also, right? The peak voltage is the maximum power voltage of your battery pack. I need that value. Okay. Yes, you have the doubt, right? Yeah.
So we have to calculate the peak value. Total, you give battery pack is
Yeah.
76 volts. Sir.
Yeah.
And we have to divide it by 76 by 4.25 or 3.65.
No, nominal.
Nominal.
Only. Then what could be the peak voltage of this one for battery pack? Yeah.
Battery pack is peak voltage.
No. Always you have to consider for nominal for this one because I mentioned for nominal. So always you have to consider 3.65 into this one. And how much series you have got? Then that is for nominal one. If you got the peak voltage, that means you have to multiply with 18 series. That is your total battery pack power. Okay.
20 series I got.
No. What is the nominal for this one?
3.65 sir.
Okay, 3.65.
Divided 76 divided by 3.65. 76 divided by 3.65. Yes sir.
Okay, so 20 series. Okay, so same thing. We are going only standard, but for this one peak voltage you have to multiply with this one series only 20.8.
3.8 into
What is the peak voltage? Yeah, 4.25.
4.25 tamru.
Okay, 83 something is coming, right? 88. So that is your battery maximum voltage, 88. That is the 100% for your battery pack. Those which is like nominal voltage there, that is the peak voltage. Sorry, that is the standard voltage. Okay. I mentioned you the peak voltage and nominal voltage. Nominal voltage is different, peak voltage is different. Okay, that is the maximum. Yes. You have to ask me, right? Okay, for you, I have said you 3 series and battery configuration, right? Have you done for battery configuration? Still confused? Okay, wait, I'm coming.
Battery configuration is given sir. I calculated.
Okay, you have calculated, right? There is my nominal voltage. Nothing but what is my battery voltage, right? 3.5 into 6 series. How much is coming? 33, 60, 18, 21, to come or something.
21.
Yes?
21.
So 21 voltage is coming. 9 parallel means that is P means AH will be getting increased. What is the AH? 4. 6 4 sir? 24 AH. So this is my 21 volt and 24 AH battery pack. This is my battery configuration. I asked for you for this one. If I ask you for this one, you will get only this value only 3, 6 and 9p. So I asked for the what is my total battery voltage? 21 volt and 24 volt. And what is the peak voltage I mentioned here? So what we'll do? Just add it over here. Just multiply it over here. 4.2. So how much is coming?
25.2.
So 25.2 is my peak voltage. AH won't be changing it. Okay? Do. Yes, you have confused. Total power. Okay, Okay, first of all, you have to find out what is my total battery pack power. So battery voltage, right? I have given you the directly 15 series and 5 parallel means what will it? So you have to multiply with this one 15 into 15 into 3.5 how much is coming? Calculate is there, very simple.
52.3.
Yes, so okay, so this is my nominal voltage 52.5 volt. What is my peak voltage? Just multiply by 4.6 into 15. And what is the voltage right now, peak voltage? Okay, so this is my total 69 volt battery pack peak voltage, but we always have to consider only nominal voltage, always standard voltage, right? So this is my 52.5 volt into 5p. How much is the AH then? What is the AH I have given? 10 AH, right? 50 AH, right? 52.5 volt is my 50 AH is the battery specification. This only I asked for you. Most of the guys I have asked for this one only, battery configuration, but I asked you for the battery power. What is the battery power? Okay, very easy, right? Concept. So okay, so that means this is my peak voltage around 69 volt. That is my 100% voltage. Okay.
Voltage into
No, there is the no voltage into no parallel only for the AH. AH won't be changing it. Only the voltage in series will be changing it. Peak voltage, right? Peak voltage will be changing it. Yeah, doubts? You have doubts? You can clarify me here. Scribbling it.
Sir, we have to dimensions, width and height.
You can, I mentioned you, right? Just circle it, top one you can make. I haven't mentioned the dimension also. Where is the dimension? Which one your cell is using it? I mentioned also. LFP. Okay, but okay, yeah, I have given you for this one. Okay, just circle it. This in series, this in parallel. That's all.
Only we have to calculate this
Circle only. If you are making like this, that will be like total different dimension. Okay, so always consider like this only, that part. Okay. Okay, you have considered for this one 3 to 700. What up for you this one? For you? I'll be asking the test and all. Yes. Where is your route?
41 maximum power.
No. I have said you for this one, right? This is my battery configuration, right? This means total battery pack voltage by 3.6, one single cell. How much is coming? 36 divided by 3.6. 10 is coming, right? 10 in series, parallel one only, right? Simple, right? Then total number of cells, how much is coming? 10 only. And battery pack voltage. Okay, I forgot the peak voltage, right? So 4.1 into 10, because we have considered for nominal, right? We are required to peak voltage. Every peak voltage will be what will happen? 41 is my peak voltage. Okay, got it? 36 is the nominal and peak voltage is 41, and AH will be same only, 2.5 AH.
What is the value of 3.65 battery, sir? This
Okay, which one you shall have choose?
that I know. 3.65, sir. Nominal value.
For it will be having different configuration. You can take anything, 18650, 26650 or 21700, anything. Yes, doubt clear? If you have doubt, you can ask me very clearly. I can give you very clearly. Where is your doubt? Don't hesitate to like asking questions and all. I'm here. I'm not your teacher. Like I will be scolding you, I'll beat you. Nothing like that. Be freely. Where is your doubt? Huh? Clear? You got it? How many series? What is the battery voltage I have given you? Okay. 200. What? How many series you require? 62. How many parallel you require? Okay. What is the total power? Yeah. What is the power? How will you calculate it? Power I mentioned here, na? 200 volt into 36. What is the power? V into I, right? What is the power then? 200 into 36. Power calculation. 7.2 kilowatt hour. Okay. Yes.
Sir, these are dimensions 376, sir. So we have to connect the 376 batteries.
No, that is the dimension. What is your battery pack dimension? That is not different.
Dimension and okay.
Length and width, how much you require, height, how much you
We
require.
have to connect 20 batteries.
Yes,
Batteries and
20
then-
wins in series. Sorry, series will be coming like this, parallel will be all this one over there. But we haven't added spaces. Yes. You made the dimension, right? You made dimension without the spaces. Spacer also some space will be there, right? Obviously there will be a gap between around 1.2 mm or 2 mm. How much mm gap?
2.09.
Yeah, 2.0 mm will be there because you require a add to, like around the cell you require to cool it down, right? Otherwise it get heated up. Okay. You can see the difference between this one here. So you can see the little bit gap is there, right? Okay, don't catch it. So you can see the little bit gap. That is for air vent. Okay. So here in this one there is no air gap. You can see it's totally attached. Only air gap you can feel it over here from the top. Okay. So this is not upsetted. Okay. This provided. Big file. Clear, right? Okay, you have what is the peak voltage you have made?
3.64.
Peak voltage. Okay, that is your peak voltage. Okay, everyone has cleared, right? Right? Clear? How to make one BMS? Yes, sure. Okay, still if you have any doubts you can ask me, then we can go for the wiring diagram of the BMS, how it is connected. Next part. Doubt clear? Anything? Take 5 minutes break. Do see the calculation. If you have doubts, you can ask me. Water. पाँच मिनट ब्रेक
माइक में कुछ बोलना नहीं है माइक निकालेंगे यार तो वहाँ तो आवाज आएगी दोबारा स्टार्ट करने से पहले बोलना होता है करने वाले प्रॉब्लम
Okay. So this one of the image of the cell testing and charging and discharging the every each cell. While going for the manufacturing for this one battery pack, we require every each cell to be get tested. What is my voltage? What is my current? What is my AH? How much time is required to charge? And you can see this the every each cell has different cell voltages. 3.5, 514 millivolt, 3535 millivolt, 3530 millivolts. So these are the different every each cells configured cells is getting charged. Okay, so maximum voltage of LFP, that is all our LFP, 32700, that is maximum around 3.6 volt. So exactly it's coming around 3.5 volt, right? So this is one of the cell charging machines. Okay, while making the one whole battery pack. Okay. Yes. Same thing, I think so. Oh yeah, 32700. This is the data sheet of that constant charge and constant voltage. Okay, so you can see the charts and all. Don't drop it, don't crash test it over here. Oh, that is NMC. It's more dangerous. So you can see the graph. The top one red is in voltage. I think so. You can see it right over here, right? 3.5 for every each cell has different chemistry, right? So you can see that there is a big difference in the millivolt. Okay, so that also in impact. And you can see over here is the current, how much current is flowing over here, and the time. I think current, where is the current? Yes, the current is over here, 41 milliampere, right? You can see the linear, how much linear is going over here, and the time period is time takes to charge per cells. Okay, so this is one example of cell charging it. Right? Got clear, right? So moving on, next is the how to connect the BMS to your cell. Sorry, the cells, every each cells. Let me open the chart. One chart will be there. only is the okay, no problem. I will draw it over here. So let us consider for 3 series. Very simple part. 3 series. It is around 12 volt, right? So let us consider. I have my volt cell of 3.6 volt, 4.1 volt, right? And the AH is around 5 AH, means 5 milliampere hour, right? Yes. So I require 3 series, 2 parallel. What is the value? Can you give me for nominal? 10. 3.6 into 3, how much? Come on. 10.8 volt. And AH, what is the AH? 8. AH I have given, right? How much? 5 AH into 2, 10. Simple calculation. Right, okay, what is the peak voltage then? 4.2. What is the peak voltage? 4.2 into 3, how much? 12 point? Okay, 12.6 voltage, right? Same thing. So this is my peak voltage and this is my nominal voltage, right? So I am expecting around 12 volts. So it is coming around 12 volt only, right? So let me draw one of battery configuration of 3S and 2P. So how will I draw? 3 in series, right? Yes or no? Yes. And 2 in parallel, means another besides. Okay, how many number of cells are there? 6. Correct? So let us I mark here cell 1, cell 2, cell 3, cell 4, cell 5 and cell 6, right? This is the N terminal of the battery pack, B positive and B negative. Correct? In order to get series, you know the series, right? So you require a 3S BMS. How many cells are there here? Okay, 6. How many series are there in here? 3, right? So you will ask only for 3 series. If you see for this one over here, it's written over here, it's around 20 series. Right, it's clearly written, right? For every battery configuration you have made, you require that BMS only. What is the S series you have written for you? How many series? Nominal, just take nominal. 16 series, right? So you require a 16 series of BMS. For you? For you? 3 20 series. What about you? 12 series. What about you? 6 series. So you require every is different BMS configuration, right? For this one is 20 series. For your requirement, you require that series. Okay? Yes. So I made for 3 series, right? So I require a 3S BMS. So how will I connect here is B negative. Obviously, right? B1, B2 and B3. So this is my connection. I have shown in the video, right? I have made one connection like battery, balancing it, the video one. How many series are there? 24 series, right? So all I have connected into 24 series. So this is the connection of the wire of 3S BMS. Okay. So here also I have to join it. Okay, so already it's joined. Right? So how many connections are there? B negative, B1, B2 and B3. Right? So there will be a 4 connections. If you see for this one, BMS. Where is the BMS? Okay, I think there is no pin connection. उसको उठा के लेके आ जाए बड़े वाले BMS. Let me show you for that one battery pack. इसको दे दो. Okay, no problem. That wire is there. Actually, we have the wiring. I will show you. Yeah, you can come over here, so you can see exactly how the battery looks like. Yeah, please. Okay, first and second row, please come over here. You can see the real time. Okay, leave it. Make sure watches and be careful with the metals and all. Light लगा दे. So actually this one is a JK BMS. Okay, so here you can see the number of series over here. So this one is 24 series, right? It's clearly written, right? B24, and here B negative will be there, and B negative you can see here on black wire will be there. Yes, can you see one here back B negative? Right, it's connected to her. Same thing I made for over there the diagram B negative. From these they totally a 24 series, so I have connection made like this. So here you can see here the plates and all. B negative, B positive, all are there. So these actually a different type of cells. Okay, you can see over here lithium ion battery, right? And this has around 3.7 volt of 30H. And how much watt hour is written here? 111 watt hours. So this is one of the battery packs. So all our wire is arranged according to that configuration. How many 3 series? So actually this is a 24 series. You can see B3, B2, B1 and B negative to balance the cells. If one cell gets also unable to discharge, it will bypass it. Okay, the BMS will bypass it and make the cell be balanced. What I have shown in the video, right? Same thing. Okay, so this is the actually output, and this is the CAN connections and all, and the wiring and all. Actually this is not a proper wiring and all, so this will be a little bit bulky. If you see in my video, you can see that it's totally properly wired, properly bolted. You can see the bolted part over here. Come from this side, so you can see the visual parts, right? You can see the bolted part, right? Lugs and nuts, right? So these are all connected with each others. 24 series. Okay, got clear, right? Any doubt in these parts? These are the BMS connection. This the B negative is written over here, right? And this is the power output. This will give you the power output, right? Clear? You can visualize from now correctly. If you have got clear, if you have any doubts, you can ask me right now or later also. And you can see the spacers.
So JK BMS, JK means what?
Oh, that is the company name. Jikong, BMS. These all are different and all. This active balance BMS is there. This for NCM and the balancer. Okay. Got clear, right? How it is made. You can see the comparison of this cell and that cell. LFP, different cells, right? So this one of this. Clear? Yeah. Third and fourth batch.
How it is used as an inverter or
Sorry?
how it is used?
Yeah, you have.
Places we can use.
Oh, sorry.
In what places we can use this?
This can be used in many appliances like traction system, power backup systems and all. Not even. Yeah, inverter also you can do.
You are spacing the batteries.
Sorry?
Spacing the batteries, sir.
Yeah, I'm making stacking it. Yeah, cooling also.
They are becoming larger in size, sir.
Yeah, that's why you
How
have to.
can we use them in motors like in
For this one is like cycle type will be there, which is used in cycles and all. This is very less only. It will go more than 30 km per hour at 30 for 40 range. That is will be very enough. These only for bigger vehicles and traction system and all. So that's why they will use only for these ones, right? Okay. We will be asking you so many also. Okay. Yes. Be careful without this. Totally is fragile. Okay. This came for the service only. Okay, so what I mentioned is here is 3 series, right? So you can see here is the 24 series. Can you see the B24 is written over here? Yes. So this is actually a 24 series battery pack, and you can see the lithium ion battery pack over here. So what is the he's written over here, right? What is the configuration is written over here? 3.7 30H, right? And 111 watt hour. Only for one cells. All our battery cells are stacked. You can see the cell stacking part over here. So from this side, all our cells are stacked. You can come over from here. From this side, you can see over here. All cells are bolted. Don't. Okay. Can you see the bolt nuts and right? Same principle, like this is a totally different part. It is bolted. Same for this one is totally different model. You can see over here, right? So all are connected to according to the configuration. 24 series means every cells are connected with the positive terminal and B negative terminal. For that one, 3 series you can see, right? Yes. All are connected according to that method only. B negative, B1, B2, B3. Can you see here is the negative part, B negative, black wire. So actually this is a B negative. If I erase it, you can see B negative, B1, B2, B3, B4, B5, B6 till B4 and B positive will be there over there. Okay, so this is how it is. Wire is connected over here through this one. These are the plates, bolts and nuts, and this is the battery pack. Clear? It can be used for the vehicle. It can be used for the aerial system or any network system over here, or UPS or inverter backup systems, right? So for example, this one is the we made for battery pack for the vehicle traction system. Okay, and you can see here the B negative. All B negative wire is connected over here somewhere else. Okay, B negative, and this is the output. B P negative, right? B negative. B negative means battery negative part. B positive will be coming out somewhere else. This totally open. Okay, clear? Got clear, right? Visualize it, and here is the temperature sensor, I think so. NTNC, what is the temperature? I think it has been removed. Okay, I'll be attaching somewhere else with the battery. It is attached with the battery, so that way it will monitor each time, real time, what is my temperature. Like I showed you that how much, what is the temperature, 33 degrees Celsius, 37 degrees Celsius. So this is how it is detected and monitored. Okay, this one over here. For example, I can show you the this one of the JK BMS. Right, you can see every each cell voltage. What is my cell voltage? What is my peak voltage? I can control from my phones. So, sorry.
Before relation, so that
Oh yeah, that is different. That is only for while manufacturing the battery pack. I need to balance the every cells like 3.339 or 3.4. You have seen, right? There will be a little bit tolerance of around 0.5%, right? So this is how you need to be charged. This is actually real time. You can see that what is every voltage has been balanced or unbalanced. You can see is all unbalanced protection cell has been increased, right? Yeah, you can see this is the balance one, 3.39, 3.07, 3.05, 3.05, 3.04. All are millivolt, 1 volt, 2 volt, 3 volt of difference. Okay, clear? Yes. You can see the capacity. What is the total capacity? 42 volt. See, these are all my battery configurations, right? Yes. Visualize it. हाँ? दिखा रहा हूँ. Okay, clear? These are the spacers. You can see the spacers. All are stacked. Clear? Once again, you visualize these things and all, and you can leave. If you have any doubts, you can ask me, or after also. Please don't touch it because it's totally open.
Where is BMS?
Hey, here is the BMS.
Okay, this one only.
Yes.
This is also
Yeah. Sorry.
I thought this is a battery.
No, this is not the battery. This is the BMS. That's why I showed you the number of configuration. Or else you can see this is the connection of this one. This is the SMD connection. Actually, this is the pin connection over here, this side. Or you can say this one over here. This is the 20 series, right? So here is the number of 20 series which will be connecting over here. And these are all our MOSFET, you know those things, and resistor, passive components, and active components will be there, right? Yes. B negative, B power output. Same as well as B negative here, power negative is output here, right? While doing on hands-on session, we'll be providing you the BMS and all the battery connection and all. From that, you can get to know how it is battery is manufactured. Okay? Yes. If you see the cell arrangement, if you see this one is the cell arrangement, it's totally unbalanced. So this is the design. Okay, this is our NMC one. Okay, I will show you in later one. This is the question. Doubt clear? Yes. So right. So actually I haven't forgot to show you this one. This one is the JKBMS real-time monitoring. So what are the data parameters which I have showed here? State monitoring. What is my voltage? What is my cell voltage? Right? Every cell 1, what is my cell voltage? Cell 2, cell 3, cell 3. So these are all the configurations. Okay, got clear, right? So I think so. I hope so. You can make your own battery pack, right? On the practical section. Yes. Yes.
Yes, sir.
No, sir. No, sir. Okay. That will come once. If something happens, it will get caught fire. Okay. Let me present you some images of without using the BMS. What will impact? Okay, so this is one of the event over there in Coimbatore. You can, as you can see. Right, you can see, right? Clearly, you can see in the newspaper or in the social media, or Twitters and all. You will get to see the real image of this one, how the battery catches fires, right? So you can see that this is the total different type of cells. If one cells also get damaged or overheated, this will happen, right? You require a proper BMS to maintain, also to properly handle the cells, right? How to make one battery pack, how to design it, what is the cooling method, every step you have to go through it. Yes, you are raising hand up. No, fine. Right? Can you see it? So another image is over here. So this will be happening like this. Proper maintenance you have to be there. Even also your cell phone also get blasted in your pocket or in yours. Right? You have seen the video obviously. Clearly you can see. Once if battery get caught fire, there is no way to stop the battery. That's all. That is the end of the battery life. And you can see the frames and all. There is nothing is there. Full empty, just a bone. Yes, got clear, right? Okay, till now you have any doubts? Yes, till now you have any doubts? No? Are you sure? Any doubts? Making battery packs or any BMS or cell configurations or cell design, the data sheet. we'll be providing you the data sheet also. You can go through it. Okay? Yes. Anything doubts? Next part is like the main part is the traction systems. How to control your vehicle, right? The motor, the electronic control unit, horn lights and all. That will be on next day session. Okay? Output is Ajay. Ajay ka Okay.
आज एनवायरनमेंट में थोड़ा सा बहुत अलग
Okay. वीडियो दिखा ना इसमें? हाँ वो खासा था वक्त में है
दिखा
On the first day I have shown you the picture of Sakasa, right, the vehicle. Do you want to see the real video of over there in South Korea? Yes? Yeah. I think you can exactly see our vehicle. Where is the vehicle? शटर तो नहीं हुआ You can see the testing facility over there. So you have to make how many number of laps you have done. Okay, totally we have made of number of laps around 24 laps. Still 2-3 laps was pending, so we have not cleared those things rounds. Okay. So another part you can say, I think so. See the car, not the girl. Every have seen it. Okay, we are not racing it. We have to follow the rules. Every rules, right? You can't turn on every each turns, right? So that's why you are making the complete one loop, like laps. How many laps you have done at particular rules and regulations? Okay. Blue, white, blue, white. Obviously, I made the car. I know that car. Okay, this is the. I think that's all we have. Okay, the real video which we have made while going for testing. So you can see over here. I think you can know the place. I think so. It's a nearby highway. And you can know the speed, how much speeds you are going.
I have shared a video on Instagram. If you can play this video.
Nagendra Verma. Senior, you're senior only. Still more is there, I think so. I think we have lot of videos while testing it. Yeah, obviously you know this place. You have visited also. You have taken photos and all. Yeah, Voltme College only. I think I hope so. There will be a vehicle over there. You can see in real time also. Okay, you can ask your faculty, automobile faculty, where is the vehicle. You can see it. I think another is there over here. Oh, sorry about the orientation and all. Leave guys. Yeah. I think so. This on the event, you can see the certified. Like I have said, we have clarified those inspections and all, right? The design inspection, the tilting inspection, right? You can see over here the tilting, whether it can withstand up to 45-degree incline or not, or more than 60. Yes, we have clarified. So those are the stickers. Okay. Can you see here over there? There is no stickers. Yeah. That means that is certified. We have cleared those tests. Obviously, you know the sirs and all, right? You might have seen it, right? Because sirs and you can see me also. Right? You can see Btech India. We have still more of e-Baha event, like off-road vehicle, I think so. Heard about e-Baha? E-Baha, you heard? No. Okay. We have also that video. E-Baha. Dirt bike, off-road bikes. Okay, that will be on next day. So this one of the go-kart by Kunal sir and Dubey sir, right? We know the condition. At time of 3 a.m. we are testing it. I hope you enjoyed the videos and all. Yes, okay. I think that's all for today. Next day we'll be going on the BLDC controllers and motors and all. Okay. Still we have plenty of videos like that. We made also